So hello and welcome everyone to a Bitcoin Optech newsletter number 293. This is our weekly session that is latest in Bitcoin tech, and this week we're going to go through newsletter number 293, which was published on March 13, 2024. As always, I'll just go through the preface of the letter so that we have an idea what topics we are going to be talking about and discussing throughout the course of this session. This week's newsletter summarizes a post about trustless on-chain betting for potential soft forks and links to a detailed overview of Chia Lisp for Bitcoiners. Also included are regular sections summarizing a Bitcoin Core peer review club meeting, announcing new releases and release candidates, and describing notable changes to popular Bitcoin infrastructure software. So let's start with the first news article of the week. It is about trustless on-chain betting on potential soft forks. It says, in the Bitcoin network, I've seen people pronounce this as Zeman. Okay, so I'm going to stick to Zeman. Zeman posted to Delving Bitcoin a protocol for giving control over a UTXO to a party that correctly predicts whether or not a particular soft fork will activate. For example, Alice thinks a particular soft fork will activate and she's interested in acquiring more Bitcoins. Bob is also interested in acquiring more Bitcoins but does not think that fork will activate. They agree to combine some amount of their Bitcoins at a ratio they both agree upon, for example, 1:1. So that Alice receives all of the combined Bitcoins, the fork activates by a certain time, and Bob receives all of the combined Bitcoins if it does not. If before the deadline, a persistent chain split occurs where one chain activates the fork and the other forbids it, Alice receives the combined Bitcoins on the activated chain and Bob receives the combined Bitcoins on the activation forbidden chain. The basic idea has been proposed before as well, but Zeman's version deals with specifics expected for at least one potential future soft fork of Optech template verifier. Zeman also briefly considers the challenges of generalizing the construction to other proposed soft forks, particularly those that upgrade and obsess opcode. All right, so firstly, let's talk about what this proposal is suggesting. It is suggesting a mechanism for betting basically on the Bitcoin blockchain. Okay, so what the author proposed is that, there are multiple mechanisms basically to signal your willingness to comply with a change to Bitcoin, right? Like there are flags. If a change is proposed, if a soft fork is proposed, there are ways through which nodes can notify people, right? Whether they're for it, whether they're against it. Like they can put up a certain flag notifying that they are for that upgrade, or they can put up a certain flag notifying that they're against that upgrade. So this is like a mechanism that the author proposes would also serve as somebody supporting something. Like for instance, you can check how many people support Optech template verifier, because the more the number of people that are willing to put their money at stake and say that, hey, I'm willing to put my money at stake that Optech template verify is going to get activated, for example, in the next 1 year. And if it doesn't happen, then I'm willing to lose 1 Bitcoin or half Bitcoin, whatever. Okay, so this is a way that in which the author proposes that you can also notify about your willingness or your belief that a certain change will happen to Bitcoin and that you're all for it. And if you feel that something is not for the betterment of Bitcoin, if you think an opcode is not needed or should not be incorporated, it can add complexity for no rhyme or reason and serves very little purpose, then you can say, hey, I believe that this opcode doesn't serve a purpose and it is not going to gain consensus in the community, and I'm so sure that if it doesn't, that if it does happen within the next one year, I'm willing to lose X amount of my Bitcoin. So for instance, two people, Alice and Bob, okay, now let's say they have differing opinions about Optech template verify. OpCTV is a proposed opcode that we have discussed about in preceding sessions. Okay, so let's say there's an Alice and there's a Bob, and one of them believes that OpCTV will get activated by block height N, and the other person believes that OpCTV will not get activated by block N. So both of them can lock their funds, like for instance in a 2 of 2 multi-sig account with a conditional script, such that if OpCTV, for instance, gets activated before the nth block height, then the person who claim that it will get activated will get all the funds, and a person who claims that it will not get activated, if it doesn't get activated, he gets all the funds. Okay, so and also like this is broadly what it is, and also what drawback it is. Okay, so firstly, the author proposes a mechanism for betting on Bitcoin's blockchain for it could be OptCTV or any proposal or any change or any upgrade. Okay. And secondly, the author has taken the example specifically of check template verify. Okay, for instance, and also towards the end, he mentions that what could be the limitations for any other proposal, and that's why he's sticking that the example that he's given is specific to OptCTV, and he's saying that you cannot apply the suggestion that I've given to every upgrade or every soft fork or every opcode. Mine is specifically works for OptCTV. It might work for something else. It might not work for something else because of the limitations of success opcode, which also we'll like discuss briefly towards the end. So let's just go through the post briefly. I hope the idea of the surface level is clear, right?
Sorry to interrupt. Soft forks are backward compatible, right? So how is it signaled that a soft fork is activated or not?
I mean, it's not. I mean, there can be two phases, right? Like you can set a threshold, for instance, like if X number of people are in favor of going ahead with the soft fork, then the soft fork gets executed. And if X number of people are not in favor of this soft fork, then it does not get executed. Okay. Now there are multiple mechanisms through which you can indicate that you're in favor of this soft fork. One could be like using a bit flag. Okay, like a bit flag for every transaction you use a certain bit flag. Let's say it's byte 1. Okay, the people who are in favor add byte 1 to the serialized format of their transaction. The people who are against it add byte 0. So there can be multiple mechanisms, and this is one of the mechanisms that the author proposes. Is that like for instance, if more people are willing to say that, hey, I'm up for this. It's something very basic in human. Even outside Bitcoin, we see this, is that if you're very sure about something, you say, I'm willing to put my money on this. I'm willing to put my life at stake for this. I know this is going to happen. So this is like, I don't think it's possible for you to maintain statistic of this specific proposal. Okay, this is basically betting. So if more people are willing to put their money on it, then you know that, okay, there's a broader consensus. But as a whole, I don't think there's possible for you to create a funnel or something and know exactly how many people are doing this. This is more or less the main purpose is betting, basically. Okay, but yes, for soft fork, it's possible for you to have a flag indicated, right? Like for instance, if you're up for a soft fork, if you're up for a SegWit soft fork, then maybe you can add version number 2, which suggests that, okay, you're up for SegWit 2. If you're not for SegWit, then maybe you can use version number 1 at the start of your transactions. Then after a certain time period, you can see the number of transactions that had version 2, and if they are very high, you know that there's a very high support for SegWit. So there are different mechanisms through which people can flag their support or their opposition to any proposed change in Bitcoin, and this has been done previously as well.
What did you mean by executed? What is executed here?
A new version of the software will be available. If you want, you can download it. If you don't want, continue using the old software.
Okay, fair. Thanks.
Yeah. Okay, so yeah, all right. We just go through the script basically. The idea I'm sure is conveyed that there's Alice and there's Bob, and Alice is that, hey, OptCTV. Alice says that I bet that OptCTV does not get activated. Okay, and Bob says I bet that OptCTV does get activated. Okay, now what both of these will do is they'll put their money in let's say 2 of 2 multi-sig account. Okay, and this is a script that will unlock those funds. Okay, now what does this script say? Hash pay to Bob, OptCTV, opt drop. Okay, now let's say by nth block, okay, they've like put a bet that by nth block, OptCTV will get activated or it will not get activated. Okay, now Bob is saying that it will get activated. Okay, by nth block. So if by nth block OptCTV is activated, then this first condition will get triggered. Okay. We know what OptCTV is. We've discussed it previously. Okay, it's nothing but you take a transaction, okay, and you hash it. So that check template verify. That template is actually the transaction. Okay, you log the outputs of a certain transaction and you hash it. So that's a template, and then you verify it using the OptCTV code. Okay, so by nth block, let's say OptCTV gets verified and Bob wins the bet. Then this first condition will get executed. Okay, so that transactions hash will be verified using the OptCTV code and Bob gets all the funds. Okay, now let's say by nth block OptCTV does not get activated. If it does not get activated, what's happened? Would somebody like to take a guess? Like, this is the script. Okay, this is the script, and by nth block opctv does not get activated, how will the script behave? What will happen? What will happen to this line? Let's say, okay, if opctv gets activated, then it's pretty straightforward. We just hash the template, we'll verify it, and the money goes to Bob. Let's say opctv doesn't get activated by nth block. What happens then? Will this line get executed, not executed? Will the script fail? What will happen? Would anybody like to take any guesses?
I think opctv was introduced as a new opcode in place of opnop. So for nodes which do not recognize opctv or which do not participate in the soft fork, for them it will be opnop. So it will be basically an opcode that does nothing. So they will just run by it and they will move to the second line of the script, and thereby Alice will be able to redeem it. Is that correct?
Perfect. Yeah, perfect. Exactly. The same as it happens with opcltv and opcsv.
Sorry guys, I could not follow this. I for some reason my internet got disconnected for like 10 seconds. Can you repeat, Shreyan, what you mentioned? How does
Yes.
the opctv will work?
Yes. So how Bitcoin allows for new opcodes to be introduced is by having opnop opcodes. Opnop is like opcode which does nothing. So in future, if somebody wants to propose a soft fork and introduce a new opcode like opctv, they can in place of opnop introduce that opcode. And I don't understand the implementation details, but if some nodes does not participate in the soft fork, they can still be part of consensus, right? So when that node is running a script which has opctv, to them it will look like a opnop code. An opnop code does nothing, so they will just run by that line without any issue or without executing it and without ending the script. So in the first line, opctv will look like opnop and opdrop, and then it will drop the line, as in drop the first execution line, and the second line will be executed after that. So that is Alice object sig verify. So Alice can redeem the script using her signature. Does that make sense?
Yeah, kind of. Kind of makes sense.
So, I mean, to add to that, Saurabh, basically there are certain opcodes. I mean, I'm sure you're aware of what opcodes are, right? Basically, on a Bitcoin stack, okay, there's data and there are opcodes, right? So let's say data is 2 and 3, and the opcode is add. So that add will take 2, and that add will take 3, and it will add and it put 5 on the stack. Okay, so opcodes are nothing but operators that manipulate data on the stack. Okay, so there are many opcodes. But when designing, I mean, you can never be certain that you'll not need an opcode in the future, right? So what has happened is that in Bitcoin, we have certain placeholder opcodes. Like, you know, they don't do anything. They are just kept there for future implementation. Okay, they are like placeholders. They're known as opnop, N-O-P. Okay, there's opnop 1, opnop 2, opnop 3, opnop 4, opnop 5, opnop 10. Okay, like that. So whenever we want to introduce a new opcode, what we do is we just change the implementation of these opnops. Okay, so opnop 2 and opnop 3, let's say, were vacant. Then we decided we want opcltv and opcsv. So instead of introducing more opcodes, the opnop codes, which are just placeholders, they don't do anything, we override them. Okay, so we take opnop 2 and change its implementation to do what opcltv does. Okay, so these are just placeholders that we've kept as opcodes, which are known as opnops, so that in the future, if you want more opcodes, we just change the implementations of these placeholders. Okay, that's what an opnop is. And if you upgrade, let's say, like, if opctv gets implemented in Bitcoin, we'll take opnop 4. Instead of adding a new opcode, we already have opnop 4, which is a placeholder. We'll just change its implementation so that it behaves like opctv. And the nodes that upgrade to opctv will see that as opctv. The nodes that say, hey, we don't want to upgrade to opctv, we are going to use the old node, they'll just see that as opnop, which does nothing, which is just a placeholder. It'll just ignore it and move forward.
Got it. Will you also be covering like how a certain opnop code is replaced with the logic of a different opcode? So for example, I'm sure like right now opnop does not have any logic inside it. These are just placeholders. Or like these are basically for most nodes, don't do anything when you encounter something like opnop 1 to 10. But certain new nodes will start behaving differently for a new opcode. For example, CTV or some new opcode. How does that functionality is learned by a node?
So basically, let's say I want to upgrade. Okay, now there's a new version of Bitcoin. Okay, that supports OptCTV. I say I'm all for OptCTV. I will upgrade my software. Okay, you say I don't want OptCTV. It adds complication. It has very little use case. It might make the code bloat. This that you are not for it. Okay, so you don't upgrade it. Okay, so when there's a script which has OptCTV, your node which is running the old software will see it as opnop. Okay, it'll just ignore it. As you can see, okay, this opctv hash pay to Bob. My node, which is upgraded, will see this as opctv. Your node will see this as opnop 4, and your node will see, okay, it's an opnop. I don't have to do anything. It will just ignore it and move forward. That is it.
Got it.
Okay, so yeah, so basically, if it's the nth block and we don't have OptCTV activated, then this line, all the nodes, because OptCTV is not activated at all the nodes will just see this, all the nodes will just ignore it, and then it'll move on to the next line, and Alice will be able to redeem the funds. Okay, so that's how this will work. But this is only specific for OptCTV. I won't want to go into details of why that is the case, because here we're using opnop. Okay, and at times we might also use opsuccess. So opnop basically is an opcode where the script execution does not fail. Okay, when the script interpreter sees opnop, it just moves forward. Okay, now there's another placeholder called opsuccess. In that case, the script interpreter does not move forward. Okay, it will see opsuccess, and if the condition is not being stipulated, the script will fail. Okay, so when you want to use an opcode as a placeholder, such that if that placeholder has nothing, the script execution should continue moving. The script execution should not halt. It just sees that placeholder, it moves forward. Then you use opnop. But if you want the script execution to fail, let's say if OptCTV is not activated and you want the script to fail, then you will use opsuccess, and you'll override the behavior of opsuccess as OptCTV. Okay, so it depends on what proposal is being proposed. Depending on that, you use either opnop as a placeholder or opsuccess as a placeholder. If you want the script to fail, then you use opsuccess. If you want the script to just ignore and continue executing further, then you use opnop. So these are the two opcodes that can be used as placeholders, opnop and opsuccess, and this is how they differ in their behavior. Okay, so like in our case, we want the script execution. In this example, we want the script execution to work. If OptCTV is not activated, Alice should get the funds. So we use opnop in this case, so that script execution does not halt. Just in case we want the script to fail, if OptCTV is not activated, then we just want the script to fail. Then we can use opsuccess, because if there's no success, then the script will fail. So that is the difference between opnop and opsuccess, and how these can be used depending on your use case. Okay, so the idea more or less is conveyed. It is primarily used for betting, and the second reason is that, you know, the more the number of people that are willing to bet, the more you get to know that a certain opcode has greater consensus in the community. So I hope, like I have a supplementary question, but as far as what the author was trying to convey, I hope that's been conveyed, like how this betting mechanism works.
Just one question: do you think it can be used for other things as well, other than potential soft forks? Just thinking out loud, if on-chain betting is possible, I think it's possible definitely for short fork, because it's a in-network phenomena. So you can verify if the short fork is actually implemented or not. So you cannot do what's called oracle on this on-chain, trustlessly at least, because you need the oracle to give you information about who won the bet, what actually happened outside of the network. So
that was my next question, and I wanted you all to answer. Do you all think, because it's a greater debate, right? Bitcoin is like an open network where people are free to express their opinions and people are free to reject those opinions. So this was like my greater or the larger question, is that, do you all think this is a use case for Bitcoin? Do you all think that we need this on Bitcoin's mainnet? Do you all think that this might add complexity? Because, like, you know, there's a movement going on, just so it's been added, which is called Ossify Now. If you all are active on Nostr and X, you must have heard this Ossify Now. There is a school of thought among Bitcoiners and Bitcoin developers that believe that Bitcoin's consensus changes should be halted. No new consensus changes should be added to Bitcoin, because we don't want to add opcodes for no reason. We don't want to add code complexity for no reason. Bitcoin should be kept like very simple, easy to maintain. Don't add complexity in it. Bitcoin does one thing, it does it well, and let's just stick to that. The only purpose of Bitcoin's existence is that it's a monetary ledger that counters inflation. It's a source of sound money, and hopefully in the future a unit of exchange. Let's not add these complex use cases like smart contracts and verifying who won a bet or verifying who won a computer program, etc., etc. So that being the question, do you all think that this is a use case for Bitcoin? Are you all comfortable with this?
I feel that Ossify now would be inviting a hard fork in future when there is something, something really groundbreaking scaling solution or something really nice if something comes up and that will not garner any traction, and it's like inviting hard fork in the future.
So like my understanding of Ossify now is that it is not apprehensive to changes in Bitcoin core as such. Okay, Bitcoin core will still have features added to it. It will still have upgrades. It will still have bug fixes. It will still have vulnerability fixes. It's just that no new features will be added to Bitcoin that change its consensus rules. So all changes that comply with consensus rules as of today are welcome and will be incorporated, but changes that need you to amend the consensus rules will not be allowed. That is what it is. So it's not that we'll not have new opcodes, we'll not have upgrades. No, we have new opcodes, we'll have upgrades, we'll have changes, we'll have features being added to Bitcoin Core, but none of them will be allowed if they are making changes to Bitcoin's consensus rules, because like that is like very critical and very sensitive. So that is what Ossify now is. It doesn't mean stop development.
I think this talk started after the knots filtering saga, is it?
It's been brewing up for some time. Not only knots, there are a lot of people believe that like Bitcoin is not like any other network, right? Many people, including myself, believe that it is the greatest avenue of humanity to counter an age-old problem of inflation. Okay, and if Bitcoin does one thing and it does that one thing very well, then we're more than happy, and we should not add opcodes or features or code complexities that add very little value to Bitcoin. If you want to bet, there are hundreds of other avenues where you can go and bet. Like, why would you want to bet on Bitcoin's mainnet when the stake is so high, when the software is probably the most precious piece of code ever written in the world? One single bug, one single vulnerability, one single loophole of adding these flashy opcodes might destroy the first and probably the last avenue of human civilization to create sound money. This is what I feel. You're also free to share your opinion. Do you think this is a use case? Are you comfortable with such experiments being done on Bitcoin's mainnet, like betting or whatever, etc.?
My hunch is like initially it was super slow. So a lot of these other coins had that advantage because Bitcoin was very slow in moving things. They used to say the Litecoin is a silver to Bitcoin's gold, or you had other networks wherein people would experiment with new things. The danger is always there. The danger being like if you modify, introduce a new opcodes, if you make changes to the way witness signatures are read, the consequences are unseen. Like you can test for all the bugs and you can test for like if the functionality is working fine or not, but how people are going to use it in the future is something that no one knows for sure. So I for one believe that it is better if we use make such changes not on the like Bitcoin, but say testnet of Bitcoin, or say some other coin which is just a fork of Bitcoin, and see for years if those changes are not affecting that network negatively, and then only folk bring it to Bitcoin.
Yeah, that's fair. That's fair.
Also, Faisal, like, what stops from, like, let's say ossification is how is ossification signaled, and even if ossification is signaled, what stops any node from adopting in a soft fork or signaling a soft fork in future? How is ossification enforced basically?
Yeah. You cannot shove ossification down anybody's throat. It has to be a conscious decision taken by the entire community. Has to be a conscious decision that is taken by every node runner, by every miner, by every developer, by every PR reviewer, by every Bitcoin core code maintainer. It's just a conscious decision that mutually the community has to take. You can't force it down anybody's throat. And also there's no polling or vote or survey. It's just that everybody agrees that, hey, this software is too precious for us to do jazzy things on it. If we make a mess of it like humans are used to, we've seen this happen in so many blockchains and cryptocurrencies, that people try and do jazzy things to beat the competition, so on and so forth, and then something goes wrong. So Bitcoin is too precious for us to do something as very jazzy that is not even needed. And if something goes wrong, then we'll probably rue for the rest of our lives.
So it's like an unwritten rule that okay, we are no longer going to touch the consensus rules. Is it that way?
Exactly. It's just a conscious decision.
Okay, so just another thing which I was
Being
thinking.
very conservative, broadly. Being very conservative about changing.
Just another thing, like let's say in future we want to add another zero to the tail end of like 1 sat becomes 10 sats. That would need a hard fork, right?
Yes, sir.
Yeah, so my thing is on Lightning, you can divide sats. So I think on Lightning you can have 1,000th part of the sat, and that's also a fair thing, or 100th part of that. I'm not sure. So if sats become super expensive, you can have L2s wherein you can rewrite the rules of whatever new currency you want to create. Of course, when that L2 will settle on L1. They will round up, or they will actually get rounded. But I think that might be a better way to handle that than to make hard fork changes on Bitcoin. The other point is there are certain changes that are bound to happen. For example, like probably in year 2176 or something, we run out of block height, or the way I'm not completely sure. There are a couple of rules that are bound to change, and if there are other changes that have to go in hard fork, the whole community can be convinced that because these changes are going, let us hard fork and introduce all the smaller changes as well whenever that happens.
Yeah, true. I mean, when we have a backs against the wall, then it's different. But the concept is to treat Bitcoin's consensus rules as something sacred, which should not be fiddled with until and unless we have completely our backs against the wall.
I also think it's a fun science fiction economics question that if 1 sat is too expensive, if 1 sat becomes worth 1 car in 2176 or something like that, then I think our problem is less about how do we denominate lesser amount of value, and more that it's not a worry anymore that we are able to produce so much value that even a car is as cheap as 1 sat. So I think at that point production should be that optimized that humans, until you're getting a car, should be able to get anything for less than 1 sat. So our energy production needs might have exceeded the need for money below that need. But I think I think hard fork will, technically speaking, I think hard fork is necessary if all of the nodes in the world have to agree that now each sat will have this many decimal points, or there will be not 2.1 quadrillion sats or 21 million Bitcoin anymore. There will be I think it will be still 2.1 quadrillion, or not? Will it be some denomination? I'm missing the math part of it.
I mean, like, I am somebody who believes that I personally don't speculate on these things. I mean, things where, I mean, I've seen a lot of people, I've seen a lot of people spending hours and hours and weeks talking about how quantum computing can reverse this discrete log problem, and discussing for hours and hours what happens when the Coinbase reward goes to zero after 150 years, what will happen then, mining will stop, Bitcoin will become centralized, and people talking about what will happen when 1 sat gains so much of value that you're able to buy a villa with 1 sat. How will you denominate it? How will you buy a bread with it when you can buy a villa for 1 sat? I mean, these are questions that, hypothetical questions might not even happen in our lifetimes. And I mean, whenever Bitcoin community is subjected with a challenge, whenever the Bitcoin community has had their backs against the wall, we've come up with answers. So when this actually happens, might not even happen in our lifetime, might not even happen in the lifetimes of our children. When this happens, I'm sure the Bitcoin community will come up with the answer. And I think there are much more important questions that are in front of us, instead of pondering over what might happen 50 years from now, 100 years from now, 200 years from now. What happens when the Unix timestamp expires? These are questions that I think yes, we might want to keep them at the back of our mind, but I don't think these are questions that I personally would want to spend hours and hours on. Might not even happen in our lifetime.
Yep.
Oh,
It's the K phenomena problem that somebody said that in the year 2000 internet will break. So it did not happen. So I think questions like this are
exactly.
better off
Right.
answered by the future.
Right. And quantum computing doesn't only threaten Bitcoin. There are a lot of things in
Right.
computer science and cryptography, even for the governments and intelligence agencies, that will, that their secrets will get leaked out the day somebody solves the discrete log problem. Okay. It's not specific to Bitcoin. The day Unix timestamp lapses, expires, it's not only Bitcoin that is going to get affected, it's every software that depends on it. And most softwares do. Will suffer. So it's not specific to Bitcoin. It's basically specific to the internet as a whole. So the internet will
Right.
come up with an answer when the time is right, and I don't think anybody among us will be alive at that point in time.
Right. And that's a good point because there's a lot of FUD around quantum computing with regards to Bitcoin. I don't understand why, because Bitcoin uses cryptographic primitives which are everywhere on the internet. It only uses digital signatures and hash functions, which are literally present in the banking system and communication technologies. And if the discrete log problem is broken, which you understand, and when you try to understand it on a information or bits level, you understand that it will literally just be a different paradigm of computing. So we have bigger problems than Bitcoin. We have a different computing technology with us. So it's literally a FUD that is created by mainstream media. I believe it's not rooted in actual adversarial thinking.
True.
By the way, there are schemes, hashing schemes and private public key cryptography schemes which are quantum computing resistant. It's just that Bitcoin did not choose them because they're not super efficient. So if it comes to that, whenever it happens, the hard fork is always a possibility.
True. Cool. So if no closing comments, we'll move on to the next article.
I just shared a meme in the chat. I think you can.
Let me see.
Relevant to the current discussion.
What's that? 18 filters. I can't see the entire meme. What's that? 18 filters. I'll have to click on it to open. Yeah, it's 18 filters. It's cropped. It's cropped, man. You have to click on both the images and open them.
Right. It says eating filters.
I think hating filters. Core hating filters in CT. Okay, I think these are people who are proposing different opcodes. Okay, and the guys who are for ossification are just enjoying that. We don't support any of these opcodes. You all can fight among yourselves. Got it. Nice. Okay, all right. Let's move on to the next one. All right. So the next one, I will just read it. It is the overview of Chia Lisp for Bitcoiners. Anthony Towns posted to Delving Bitcoin a detailed overview of the Lisp variant used by the Chia cryptocurrency. Towns has previously proposed a soft fork introduction of a Lisp-based scripting language for Bitcoin. See newsletter number 191. Anyone interested in the topic is strongly encouraged to read his post. So we all know Bitcoin has a script, right? Bitcoin has a locking script, which is referred to as the script pub key. Bitcoin has an unlocking script, which is referred to as the script sig. Okay, there's a condition in the script pub key or the locking script, which has to be triggered or fulfilled by the unlocking script, and that is how the coins are spent. Okay, and the programming language which Bitcoin uses to do this is known as Bitcoin script. Basically, it's a lower level programming language that uses stacks, which comprises of two parts, data and opcodes. So the data is on the stack and the opcode manipulates the stack. And most of us are well aware of the fact that this programming language has very limited features, which is considered to be like a virtue as far as Bitcoin is concerned, because it prevents in inducing unwanted bugs and unwanted complexities in the code, and retains Bitcoin's reputation as quote unquote a dumb software, which is a compliment. Like it just does a few things. It just does what it is supposed to do, and it does it very well. Okay, it doesn't think out of the box. Bitcoin is a software that doesn't think out of the box. It just does what it's supposed to do. So quote unquote that's referred to as a dumb software, which is like a compliment to see in context with Bitcoin. Anthony Towns suggests that we need a new programming language in Bitcoin. Okay, and this proposal has been there for quite some time. A programming language that was being worked on is referred to as simplicity. So there have been talks about replacing Bitcoin scripting language with a new programming language called simplicity, which retains the simplicity of Bitcoin script and adds some new features which a school of thought might believe that is needed. Okay, it's again a to and fro, and some people believe it's not needed. So here's another proposal by Anthony Towns. He proposes a language which should be on the lines of Chia Lisp. What's Lisp? Lisp is a programming language that was invented in 1958. It stands for list processing. Okay. It's a programming language basically that makes use of this data structure called linked lists. Most of us who've done data structures know what linked lists are. So broadly, there are two ways to store a list of information or elements in your computer's memory. The first is array, which we all know. The second is a linked list. I will just share my notes if I can. Let me see. Notes are visible in that untidy handwriting. That's English Bible.
Pretty good, pretty good.
Yep.
Yeah. So this is an array. All of us know us. Okay. So if I give you 4 numbers, 1, 2, 3, 4, tell you store them in an array, we know this is an array. Okay. 1, 2, 3, 4. This is index 0, index 1, index 2, index 3, first element, second element, third element, fourth element. Okay. And the address. Okay. So let's say an integer eats up 4 bits. So the address of the first element is 1000, the second is 1004, the third is 1008, the fourth is 1012. Okay. What's specific about arrays is that the addresses are sequential. Okay. You cannot have the second element at 1004 and the first element in 1008. That's not possible. All right. They have to be in sequential ascending order. The first element has to come before the second before the third before the fourth. They have to be in sequence. How do linked lists differ? Linked lists are basically, they do what arrays do, but you can scatter them. Like you can randomly arrange them in memory. So if I give you these 4 numbers, 23, 54, 78, and 90, and tell you to store them in a linked list, what a linked list does is basically a linked list contains of a node. Okay. Arrays have cells like this. These are 4 cells. A linked list has nodes. Okay. This node contains of 2 parts. The first is the data and second is the link. Data stores the actual element and link is the link to the next node. Okay. So if I give you these 4 numbers and I tell you save this in a linked list, this is how you'll do it. Okay. This is a node, first node, second node, third node, fourth node. Okay. The first node has data 23 where you stored the actual data. It has an address 1000. Okay. The second node is this. It has the element 54 and this is the address of that element 2000. Now the first node will have the address of the subsequent node 2000. Okay, that is how it is linked. So for the purpose of convenience, I've used this address in sequential order 1000, 2000, 3000, 4000, but they can be random. Like the first one can be 4000, the second can be 2000, the third can be 5000, the fourth can be 50, whatever. Okay, randomly. So how do you link them with each other? With this. Okay, with this. You see, okay, this is the first element because this is the head. This is the first element 23, which is the second. Okay, it's at address 2000. Okay, here you can't do that. Here the first cannot be 1000 and the second at 2000. Here they have to be in sequential order 1000, 1004, 1008, 1012. Nothing can come in between them. All right. Here you can have like the first element at 1000, then 1004 to 1099, 999. You can have anything, and the next one comes at 2000. Then again 996 addresses. You can have anything. The next comes at 3000. So they need not be in sequential. You just have an address over here which tells you okay, the second element as for the second element. Go to this address and link it with the first element. So this is what a linked list is. And Lisp basically is a programming language that makes use of lists. So we have stacks in Bitcoin scripting language. Lisp has lists. There's a cryptocurrency called Chia, which makes use of this. Okay, so like in Bitcoin, we have Bitcoin scripts. Chia cryptocurrency has a variant of Lisp programming language, which is known as.
So yeah. Fazil, in here, so this in its linked list, the data is 23 and the number and the what is the data is 23, right? And
right.
And the position is 2000.
No, this is the position of the next element.
Oh, the position of the next element. Got it.
Yeah. Okay. So I tell you 23, 54, 78, 90. Okay. You're at 23. I give you the head. This is the head. Go to 1000. You'll find 23. You find 23. Now where's 54, right? In an array, you know it's at the exact next memory location that is available. But in a list, it can be scattered all over the memory. It need not be sequential. So how do you find it? So you go to 23 and now you're looking for 54. Where's 54? So 23 will tell you, hey, go to 2000, you'll find 54. You go to 2000, you find 54. Then you're looking for 78. Then you go to 54. 54 tells you, hey, 78 is at 3000. You go to 3000, you find 78. And 78 tells you, hey, the next element is at 4,000. So you go to 4,000, you find 40. So this is how they are linked. That is why they're known as linked list. And then the final element will tell you null. It means this is a tail. This linked list ends here. Okay, so this is like a generalization of a data link. Here is the data 23, and here's the link 2000. That's clear.
Yep.
Yeah. Okay. All right. So yeah. So basically, we have stacks in Bitcoin scripts, and we have linked lists in Lisp. And Chia Lisp is a programming language which is a variant of Lisp programming language, and it is used in this cryptocurrency called Chia. Okay. Now the author proposes that this has quite a few. I mean, this is an upgrade. I mean, we will not. He doesn't plan to implement Lisp in itself, nor does he plan to just pick up Chia's variant of Lisp and use it in Bitcoin. He says that we will use a variant of Lisp, just like Chia cryptocurrency has used a variant of Lisp language. Okay, we will also take Lisp language, its foundations, and create a new language and call it Bitcoin Lisp. Like Chia has Chia Lisp, we use Bitcoin Lisp, and we'll replace it with Bitcoin script, because he believes that there are some functionalities or some added features that Lisp has, which Bitcoin script doesn't have. And this is just an implementation of how it works. We've all seen in Mastering Bitcoin how the Bitcoin's stack is executed, right? Like for instance, if I tell you 5 and 4 and 3, then 5 will be on one stack, 4 will be on the other stack. Then there'll be an opcode, op-add. Op-add will take 5 and 4 and it'll add it. So this is how this is how Lisp works. All right, this is a command. Okay, this is a program that you've written. Okay, so what Chia will do or Lisp will do, Chia Lisp will do is it'll take 4, it'll take 5, it'll add and give you 9. So this is how you add numbers. So let's say there's something on in a list and there's another thing in a list and you want to add them. This is how you add them. All right, and this data is encapsulated in the form of concells, consecutive cells. So this 4 will be in a concell, 5 will be in a concell, and this addition side will be in a concell. If I give you 5 and 4 and tell you subtract 5 from 4, this is how you do it. Okay, this is how you multiply. This is how you divide. You take 5 and 4 and then you divide it. Okay, and for a floating point number, this is what you do. If you want the remainder or the modulus, this is how you do. Now in Bitcoin script, we have these opcodes, right? Opcheck, sig, verify, opcheck, sig, so we also have op equal verify. You know? We take, for instance, a public key, we hash it, we verify it with the hash. If it matches, then the script for a P2P chat address is executed. So this is how we check for equality in Lisp, like equal 10, 10. If it's equal, if both the parameters that you supplied are equal, then it'll give you true. This is how you use conditional statements. Okay. So you define a variable by the name of age 18. This is how you write conditional scripts. Okay, so if the age is 18, then you can print out, you can vote. If it isn't 18, then you print out, you can't vote. So we have like if and else statements in a Bitcoin script language. This is how Lisp does it. Okay, and it makes use of linked lists instead of stacks. This is how you write functions. Okay, modulo arg1, arg2. Then you can pass argument 1, you can pass argument 2, and this will add it. So you can pass 2 and 3, and you have this function. So it'll add and give you 5. This is how it's done. Now, yeah, some other behaviors that I kind of noted down for myself. These are my notes, like how you hash and verify. Right? You take a password, for instance. It could be a pub key or anything. You hash it and verify if the SHA-256 hash is equal, and if it's equal, then the conditions will be met, and then the script will be unlocked. So yeah, it is said that this programming language has less opcodes. Like Bitcoin script has more opcodes. You need to incorporate more opcodes in the code base to do things. And if you use like a variant of Lisp language, you will have to use less opcodes. Also, it supports loops. It is a language that supports recursion, which Bitcoin scripting doesn't. So you can use loops to do something continuously. Like for instance, if you currently want Bitcoin script to perform the same function again and again and again, you'll have to use that many opcodes. So if you want to add 2 plus 3, then again 2 plus 3, then again 2 plus 3, then again 2 plus 3, you will have to use that many opcodes, right? 2 plus 3 op-add, 2 plus 3 op-add, 2 plus 3 op-add, okay? But with loops, what you can do is just loop it, 2 plus 3 and again 2 plus 3 and again 2 plus 3, and you keep on doing for as long as you want to, until and unless it does not reach the script limit. And this again comes or boils down to the same argument or discussion or schools of thought, whether you want Bitcoin to be a dumb software, whether you want it to have loops. There will be people who say Bitcoin should not have loops, it should be Turing incomplete. There should be people who will say that Bitcoin should have loops, and those who say Bitcoin should have loops might advocate for a new programming language like Simplicity or a variant of Lisp programming language. And those who say we shouldn't have loops will want you to stick with Bitcoin script. So that is again the same discussion that we've had so many times. So this is a proposal basically by Anthony Towns. You can go into this, like click on this and read his entire discussion. It's a very long one. Broadly, he is proposing that we introduce a new programming language which will be a variant of Lisp, and he proposes to call it Bitcoin Lisp, just like the Chia cryptocurrency using, and they're calling it Chia Lisp. And instead of stacks, we'll have linked lists, and it'll have more functionalities, and it'll do the same thing in less opcodes, and it'll be more robust and more flexible. And he's given the reasons in the post. So you might want to go through it and agree or disagree. That is what the proposal is all about: a new programming language for executing Bitcoin scripts. Any thoughts, comments, or should we stick to Bitcoin script or whatever you'll have anything to say?
I don't think it's likely to happen, but the surface area for attack just increases many-fold by changing. But if Chia remains successful for a couple of years, maybe people can look into it. But yeah, that's what my hunch is. But yeah, happy to hear from others.
I'm just curious if there's a specific use case why this is advantageous in some fashion compared to Bitcoin script.
Some reasons that. Okay, guys, I might not have internet in a few seconds. If I get disconnected, I'll probably use the phone because there's a power cut. All right, for now I have internet. Y'all can hear me, right?
Yes.
Yeah, I can.
Cool. Yeah, just in case I get disconnected, please be patient for 5 minutes. I'll use a hotspot or something, but for now it's working. Okay. Yeah, one use case he mentions is that, from what I understood, from what I read from the article, and from what my inference was, is that firstly, one thing that I could deduce is that it uses less opcodes. Okay, so like the code will have less complexity because each opcode has to be ingrained in the code base, right? If each opcode's implementation needs to be written in code in your software that you are using. So the lesser opcodes we have, the less burden we have, the less code complexity we have. Let's say, for instance, a Bitcoin scripting language currently needs 100 opcodes to perform everything that we expect Bitcoin to perform. Then maybe a variant of Lisp can bring that number down to 50 opcodes. So instead of having 100 opcodes, now you have only 50 opcodes, and each opcode can do two things of what the previous opcode was doing. One, again, like I said, is looping. And you can loop now. People who believe that Bitcoin's language, like Bitcoin's programming language, should support loops. Because we're depriving ourselves of many features because of the limitations of current Bitcoin script language, then they might advocate for it that, hey, we need a language that supports loop. I think Ethereum has a language already which supports loop, and a lot of cryptocurrencies have languages that are Turing complete. So they might go for it like, hey, we want loops. This is what we want. And also one reason is that, Chia Lisp does not distinguish between data and codes. Like current Bitcoin scripting language distinguishes between data and code. You can't put code on the script, right? You can only put data on the execution stack, and that data is manipulated using opcodes. So like you cannot induce, once the script has been created, you cannot add any unwanted data, unforeseen data onto the script. It will reject the code. But Chia Lisp also allows you to put code. Like it does not distinguish between data and code. Okay, so if, for instance, you want to add some code on the script itself, okay, then Lisp or Chia Lisp does not distinguish between data and code. And there might be many other reasons. These are few that I'm quoting. So yeah, that could be the reason to the people to whom it appeals.
Right, makes sense. I think loops part that you mentioned, that Ethereum and Bitcoin are missing out something, is very important, because I see that a lot, because BitVM also recently claims to have made Bitcoin Turing complete by being a layer 2 technology. So I don't necessarily understand if it's just a theoretical milestone that we want to achieve, that you can write loops or Turing complete contracts on Bitcoin script. But yeah, so Bitcoin is money, like we discussed, and the consensus should be as simple as possible. And for a money to have a spending condition which has a loop, I don't necessarily see how that could be useful. But I think, yeah, so from a computer science standpoint, I think that it might be interesting. Not as a use case, I believe.
Yeah, true. Like again, depends on which school of thought you believe or you align to.
The use case is a lot of stuff that we are using descriptors for, or we have come up with optimized way of writing an opcode to achieve a certain kind of inheritance or certain kind of multisig. All of that can be done much more easily with a Turing complete
like smart contract language. But of course, it should not. I mean, keeping it in L1 will just increase the surface area for attack so high that it should not, in my opinion, should not be done. But if it is being done on L2, that's totally okay. If one fails, we can always switch to some other L2.
Right.
True. And
That's
another argument
interesting.
always is not that looping does not add any features. I mean, people even who are not for it agree that yes, it'll add features, but the question always is at what cost?
No, that's an interesting point. I think it might help with inheritance or some multi-sig format. Yeah, I'll have to look into it. But yeah, my first hunch was honestly, I was just curious that why do we want to, what is the addition that it brings? Yeah, maybe inheritance and multi-sig is the answer.
Looping can have many use cases. Like any general use case, if I tell you, if you want to perform one operation n number of times on the stack for whatever reason, for whatever reason you want to
Again, it's
perform
like a
one
computer
operation.
science. I understand it being very useful in computer science, but imagine it being like a trade, right? So you're locking your UTXO for some specific contract. Now you want the spending condition to be unlocked. So I'm just pushing against this argument. I'm not saying that I have the answer that it's not useful, but
True.
I'm trying to understand if somebody could come up with some use case that I'm locking my UTXO to a loop, and only if you go through that loop a certain number of times, or if you so there's like if else condition. If you not not an if else condition, it's like a for loop, right, or a while loop.
Right.
So something to think about. I'll also look
Even
into it.
I'm like very conservative. Like if I'm very apprehensive to new changes to Bitcoin because it's so precious, it's so unique, it's so unprecedented. Under no circumstance should we, even if there's 1% of chance of something inducing a bug in Bitcoin, then we lose this opportunity for the rest of our lives. Most people here believe that Bitcoin is not like once in a century. It's not once in a lifetime, probably once in a civilization kind of a thing. I personally believe we've never seen something like Bitcoin and we'll never see something like Bitcoin. And that is why I belong to that conservative school of thought where I don't demean other people. I don't put down on the other people. I don't call them scammers or whatever. But I personally, in a very civilized and a very rational manner, belong to a very conservative school of thought who's completely apprehensive and very critical of inducing any change to Bitcoin, which is not absolutely needed. I feel Bitcoin should not be changed until and unless we have completely our backs against the wall and the change is absolutely needed. We just can't do without it. But then that's my opinion.
Right. That's also why BitVM is actually interesting, because it abstracts away any complexity and trade-offs on the base chain layer. It's a layer 2 technology. So if somebody wants to do it, you can still do it on Bitcoin, but the cost is to maintain data off chain. And if somebody wants to participate in that, they are free to do that.
All right, cool. So this week we had only 2 news articles. We move forward. Okay, guys, I mean, we're at 8:58. I'm enjoying, so let me know if you want to continue, if you want to discontinue or whatever. Okay. If most of you believe that we should call it a day, we'll call it a day there. Okay. So yeah, and this is a monthly feature. Okay. Generally, we have Bitcoin Stack Exchange questions, but this week, like once in a month, we have a PR review club. So there was a PR review club done by Armin Saburi, which was about re-enable opcat. This is another opcode. Like throughout the day we've been talking about, or throughout the session we've been talking about opcodes now. So this is another opcode which was initially a part of Bitcoin Core. In 2010, it was retired by Satoshi Nakamoto. There are calls for it to be reintroduced, and it is believed that it can implement a version of governance, because there are multiple mechanisms or versions that are being, or multiple manners which are being proposed through which governance can be achieved. Some people believe it's through OpCTV. Some people believe it's through opcat. Well, and other proposals as well. So there's a lot of talk about re-enabling opcat. Okay. So anybody knows what's opcat basically? All it does is it concatenates. It's very simple. Just like op adds, just like op multiplies, opcat, all it does is concatenates. So it'll take 2 elements from the stack. Okay, the element that is on top of the stack, the element that is on penultimate of the stack, and it'll just concatenate those 2 elements. Like any basic programming language that you write has a function or a feature or an operator that concatenates 2 things, or a method that concatenates 2 things. And I'm sure all of us know what concatenation is. It just concatenates. So that is what it does. Okay. And currently, I think it's being tested, if I'm not wrong, on Signet Bitcoin Inquisition, and only for tap script. Okay. So I'll just read through it. Re-enable opcat There's a PR by Armin Saburi that reintroduces the opcat opcode, but only on Signet Bitcoin Inquisition and only for TypeScript. Satoshi Nakamoto disabled this opcode in 2010, probably out of an overabundance of caution. The operation replaces the top two elements on the script evaluation stack with the concatenation of those elements, as the name suggests. So yeah, the proposal initially is to first test it on the Signet Bitcoin Inquisition. Okay, so Bitcoin Inquisition is a fork of Bitcoin code. You must have heard this name multiple times. Bitcoin Inquisition. I think it is maintained by AJ Towns or Avachao. I'm not really sure. On one of them. Let me see. Bitcoin Inquisition. Who's the maintainer? Okay, fine. I posted in the group. It's Avis Rao. It's AJ Towns. Yeah, it's Anthony Towns. Sorry. Yeah, it's Anthony Towns, not Avis Rao. So he's the maintainer of it. It's just a fork of Bitcoin Core where you can basically test things on Signet before applying them on mainnet. Anybody would like to take a shot on what's Signet? There's a mainnet. There's a Signet. There's a Edge test. Anybody would like to take a shot on what's Signet? Signet. Yeah.
I'm not. I did read about it in one of these books. I think in testnet the problem was that there used to be a lot of discrepancy in the new block creation. So in Signet the block creation has been is pretty smooth. Like I think it's a fixed time and a new block comes in that. Is that what Signet is?
Yeah, it absolutely is like that. The thing is, mainnet and testnet both depend on proof of work. New mines are blocked based on proof of work. Okay. Now the mining difficulty is very high on the mainnet, so it's not possible to increase the time span in which blocks are generated abruptly, because you need like a very high amount of work to rapidly and drastically increase the rate at which blocks are being produced on the mainnet. But because not a lot of people are mining on the testnet, it's possible for somebody or a group of people to induce a lot of computational power and rapidly decrease the difficulty of the testnet. So what will happen is that instead of 10 minutes, generally on the mainnet, on an average, we have a block which is mined in 10 minutes. Testnet, the purpose is to keep testnet as close to mainnet as possible so that you can simulate the behavior, right? Testnet should behave like mainnet, only then it makes any sense for you to test something on testnet, okay? If it's not behaving like the mainnet, it's not a testnet anymore. So if you induce a lot of computational power on the testnet, if a lot of people start mining on the testnet, what happens is that instead of 10 minutes, we'll probably start having blocks in 1 minute. 1 minute, right? And then it's not a testnet anymore because you cannot test the behavior of mainnet. If the mainnet is producing a block in 10 minutes and the testnet is producing a block in 1 minute, it's not a testnet anymore. You can't test anything because it's not emulating the behavior of the mainnet. And also if nobody starts or very few people are mining on testnet, then maybe the block time becomes 100 minutes, okay? And then again, it's not a testnet. So you want testnet to behave like a mainnet. How you do that? Because you can't govern proof of work, right? You can't govern how many people are mining. So Signet was introduced. What is Signet? Signet is centralized. Okay. So in Signet, you mine a block using a signature. You don't actually invest computational power. Blocks are not mined using proof of work. They're mined using signature. So you need to produce a digital signature. If your digital signature is verified, the block gets mined. Okay. So you can create your own signet. I can create my own signet. Okay. And in that signet, I want a block to be mined every 10 minutes. After every 10 minutes, I will produce a digital signature which verifies my authenticity, and a block will be mined. So it's like that. It's basically a net in which you use a digital signature. A digital signature is authenticated to mine a block and not proof of work is used. So you can control. For your use case, if you want a block to be mined in 20 minutes, then you produce the block in 20 minutes. If you want for your use case, for the block to be mined in 10 minutes, then you do that in 10 minutes. Okay, if you don't have to depend on the computational power, on the difficulty, etc., you just produce a digital signature and you mine a block. That is what Signet is, and the name Signet comes from the signature. Okay, so yeah, Signet Bitcoin Inquisition, which is maintained by Anthony Towns. So he tested Opcat on it. He did a PR review. Okay, there are some questions from the PR review. I'm not really sure we want to go on that. We don't have that much of time. Okay, so anybody wants to go on to this, these questions are nice questions and not that difficult. Like they're very easy to understand. So you can go through these questions. In the next 10 minutes, I'll try and wind up the release and release candidates and the notable code and documentation changes. Okay, it's pretty straightforward this week. So the first release and release candidate is the Core Lightning. Version 24.0.2.1 is a minor update to this LA node containing a few minor fixes, improvements in the cost function of the routing algorithm. So Core Lightning is an implementation of Lightning Network. Okay, the version such and such has a minor update. It's a minor update over the previous version. It has a few minor fixes, improvements, and in the cost function and the routing algorithm. So there's a routing algorithm like we've all covered in the Lightning Network. All right, you first determine the path that you want to choose for routing, okay, and what algorithm you use. Different wallets and different implementations might use different routing algorithms. So it seems that the routing algorithm that Core Lightning was using has been enhanced and optimized. So this is like a news for people who are using Core Lightning as their Lightning Networks implementation. The next one is Bitcoin Core 26.1 RC is a release candidate for maintenance release of the network's predominant full node implementation. So we'd like to discuss in the last session, okay, how this nomenclature works is generally, okay, I don't know if this is thumb rule. If there's Bitcoin 26 and there's Bitcoin 27, so generally Bitcoin 27 will have like major upgrades, like major software changes as compared to 26. But if there are like minor changes and bug fixes, it will generally be 26.1, 26.2. So if you have 26 and then you see 26.1 or 26.2, it generally has like bug fixes, vulnerability fixes, and some minor upgrades. But if you go directly from 26 to 27, then it generally has like major updates. So yeah, 21.1 RC is a release candidate. It's a candidate for being released. Okay, so whoever is using Bitcoin Core 26 can in the future update to 26.1, which might have some small additional features and might have some bug fixes and might have some vulnerabilities, minor vulnerabilities that have been fixed. The third one is Bitcoin Core 27.0 RC is a release candidate for the next major version of the network's predominant full node implementation. So like after 27, 26, 27 is going to be the next major release. So if you have 26, you can upgrade to 26.1, which might be launched in the future for bug fixes, etc. And the major release that will have major upgrades and added features is 27.0, which is again a release candidate and is being worked on. Notable code and documentation changes. LND PR number 8136 updates estimate a route fee RPC to accept an invoice and a timeout. A route for paying the invoice will be selected and a payment probe will be sent. If the probe successfully completes before the timeout is reached, the cost of using the chosen route will be returned, otherwise an error will be returned. So I was very keen on covering this in detail, but I don't think time will permit us. So basically this is an RPC call, estimate route fee. Okay, so like LND, which is again an implementation of the Lightning Network, it has this RPC which you can trigger to fetch the estimated routing fee. So if you want to route a payment, you use this RPC. It tells you what's the estimated routing fee. It gives the user an idea, gives the user's wallet an idea how much fee they will have to pay to route a certain payment. So like what has been done is that two new arguments have been added to this RPC call. The first is invoice, that is you supplied an invoice which has information pertaining the sender, the recipient, the amount of money that has to be transferred, and you add another argument to it which is known as a payment probe. What's a payment probe? In the Lightning Network, you can know the capacity of a channel, okay, how much capacity the channel has, but you cannot find the balance and the liquidity. You cannot, I mean, you know that Alice and Bob has a channel which has a maximum capacity of 1 Bitcoin, but you cannot find how much belongs to Alice at this point in time and how much belongs to Bob at this point in time. That information is confidential for privacy reasons. But there are mechanisms through which you can find that, which is known as payment probing. So what you do is you send a payment through a specific channel. If that payment gets rejected, then you know that this channel, like it, I mean, then you know if it gets rejected from Alice's side, then you know that Alice does not have it. For instance, you want to route 10,000 sats via a channel which is between Alice and Bob, and if it reaches Alice and it gets rejected, then you know that Alice does not have 10,000 sats. So this is a mechanism that is used, that you route payments through channels and you don't actually want to send a payment. The only purpose of sending this payment is to check the balance that the channel partners have and to access information to this confidential information. This is again a trial and error method. So yeah, you can add two new arguments or parameters have been added to this RPC call, invoice and payment probe. So you can use an invoice which stipulates the information about the sender, the recipient, the amount of money that you want to pay, and then a payment probe is sent by a wallet which checks basically if a path is a legitimate path, if there's adequate channel liquidity in that path, and if there is, then it will fetch the estimated fee that you'll have to pay to route that payment and return back to you with an estimate fee. So you can decide whether you want to pay that fee or you don't want to pay that fee. And the next one is LND PR number 8499, which makes significant changes to the type length value types used for simple taproot channels in order to improve LND's API for it. We aren't aware of any other LND implementations currently using simple taproot channels, but if any are using it, be aware that this may constitute a breaking change. Type length value is basically a format, a serialization format, right? Like in Bitcoin, we have digital signatures which are standardized so that multiple Bitcoin nodes can interact with each other. And currently, I think it's DER, distinguished encoding rules. Likewise, the data in which information is transmitted in the Lightning Network is serialized in a type length value or TLV format. So LND is currently, I believe, the only implementation of Lightning Network that supports taproot channels. That is, you can use P2TR payments to fund to inject liquidity in your Lightning channels. Okay, and they have like enhanced or optimized the serialization or the type length value, which is used for transmitting data across multiple nodes. This is what that PR talks about. The final one is LDK PR number 2916. It adds a simple API for converting a payment pre-image into a payment hash. An LN invoice includes a payment hash to claim a payment. The ultimate receiver releases the pre-image corresponding to that hash, and each hop along the path uses the pre-image it receives from its downstream peer to claim the payment from its upstream peer. Since a hash can be derived from a pre-image but not vice versa, receivers and forwarding nodes may only store the pre-image. This API allows them to easily derive the hash on demand. So I'm sure most of us who have a surface level understanding of Lightning Network know what HTLCs are. And to unlock a payment that is locked in an HTLC, you have to furnish a pre-image that unlocks that HTLC, and then you can redeem the fund. And it's the recipient that has that pre-image. The recipient shares that pre-image with its predecessor, and the predecessor hashes that pre-image and unlocks the HTLC. That is how the recipient gets the fund. And then every node in the path does the same to redeem their funds, because every node that is a part of the entire route has their funds locked in the HTLC, and they need this pre-image, which is like a key that unlocks the HTLC. So what LDK, which is another implementation of the Lightning Network, has done is that they've introduced an API which will automatically hash the pre-image and convert it into the payment hash to do or to like unlock the funds that are locked in the HTLC. It makes it more convenient. I think the mechanism earlier was more complicated and was manual. Now there's an API integrated in LDK, which will convert a payment image into a payment hash, which can be used to redeem the funds that are locked in an HTLC. We've come to the end of this session. We had like 3 notable code and documentation changes, 3 release and release candidates, 1 core PR review club, and 2 news articles. And that is all we had for this session. We have crossed our 1 hour mark. If anybody has anything to share, any questions, any closing comments, please feel free to go ahead.
Thank you, Fazal. Great job as usual. This was shorter Bitcoin Optech, so we covered everything and quite in detail.
True. I mean, like this probably, could have been like very long. We could have taken this up to 3 hours, but then it's out of the purview. There are so many things. I mean, I definitely encourage whoever has time to go, because there's a lot to learn in this. Okay, I had my notes which I made for myself, but I wasn't able to go through them exactly. Like we briefly discussed what routing algorithms are, right? I wanted to discuss exactly what a routing algorithm is, what steps does it follow, and I wanted to discuss exactly how a TLV looks like, type length value format, and what's the short channel ID, amount to forward, outgoing value. And I want to discuss all these things, but obviously due to time constraints, it's not possible to cover the Optech newsletter in detail within 1 hour. But I hope we did like justice to the letter itself, and whoever wants to dig deeper obviously has the option to do it on their own. But yeah, thanks for being there. Thanks for participating. And if nothing else, we can call it a day.
Sure, Fazal. If in case you are okay sharing your notes, we can include that in our YouTube recording, as in just the notes. But if you think it's not appropriate, you can feel free not to.
I can 100. There are two things. I can 100% share my notes, but firstly, they're very shabby. So I don't know if anybody would like to would understand it. The second is, if that is possible, I'd be more than happy to make like neat notes and come up with for the next Optech sessions. If that is possible to incorporate in the videos, I can make neat notes and share it with you for every Optech session.
Yeah, I think that'll be amazing. We will include those notes, the PDF link, sorry, the Drive link, in our YouTube videos as well.
Great. How do I share it with you before the session, after the session, or any time?
Session we uploaded like a couple of days after the recording, so I think you have you have a lot of time. You have 3-4 days. You can share it.
I'll probably try and because obviously I'll make the notes before the session. I'll probably try and share it like an hour or two before the session in the general chat section, if that's okay with you. Okay, when I say 30 minutes are remaining, so that if anybody wants to keep those notes open and refer to it while I'm talking, or some diagrams or something, it might even help the participants.
Yep. That's a great idea.
All right, thanks for coming up with it. Okay, then we'll call it a day. Thanks a lot for participating, everyone. Bye. Good night.
Thank you, guys. Bye.